Dear students, in the last class we learnt about the that fructose is a honey sugar, lactose or a fruit sugar. Okay, it occurs in combination with glucose and it can beat sugars. The most important source of fructose is the polysaccharide insulin, and the structural elucidation of fructose is the molecular formula is C6H12O6. It is determined by the molecular and elemental analysis. Fructose on catalytic hydrogenation is reduced to sorbitol. A hexahydric alcohol is formed, and also on complete reduction with concentrated HI, it gives a N-hexane. It is a linear structure, and fructose forms cyanohydrin and N-oxime. It is react with HCN, it gives a cyanohydrin. It is reacts with NH2OH, it gives a oxime. Okay, and as a carbonyl compound. And fructose reacts with acetic anhydride, it forms a fructose pentaacetate because it has a 5 hydroxyl groups. And fructose on oxidation with nitric acid, it gives the mixture of tartaric acid and glycolic acid, so that it can conclude that it has a lesser carbon than parent fructose. It is confirming that the presence of ketonic group that is should be present on the second position. Both glucose and fructose form same osazone with excess of phenyl hydrazine. Therefore, configuration is same at C3, C4, C5 as glucose, but osazone formation involves at C1 and C2 in fructose. Okay. This is the structure of fructose based on the above information. At second position, it has a C double bond O group, keto group. There will be changes in first and second carbon atom, and all other carbon atoms should be same as it is in the glucose, D minus fructose. Last class we learnt about the structural elucidation, and in this class we continue the reactions of fructose. Okay, same as it is in the glucose, like that here also the reaction should be same as it is in the glucose and also fructose. Okay, first one is with hydroxylamine. It means NH2OH. Okay, first you have to write the structure of fructose. Here structure of fructose is CH2OH, C double bond O, ketone group is present, and in the glucose aldehyde group is present, CHOH, COH, COH, H, CH2OH. Okay, this is fructose. And in the hydroxylamine, what will happen? In the presence of C double bond O, it means oxygen atom should be replaced by NOH group. It means minus H2O is removed. Okay, here this will be removed. So then the structure is CH2OH, C double bond N OH, C H OH, C OH, H, and then C OH, H, last is CH2OH, and this is oxime. How oxime is formed? Fructose is react with hydroxylamine with the removal of water. It gives a oxime. Okay. Next, second one is with hydrogen cyanide, HCN. What is formed? It forms a cyanohydrine. Okay, here CH2OH, C double bond O, CHOH, C OH, H OH, H, and this is CH2OH. Here HCN. Okay, HCN is added to the fructose. Here this oxygen and hydrogen is bonded, so then it forms OH group. ಇಲ್ಲಿ ನಾನು ನಿಮ್ಗೆ ಅರ್ಥ ಆಗಲಿ ಅಂತ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ, ಬಟ್ ಎಕ್ಸಾಮಲ್ಲಿ ಈ ಥರ ತೋರಿಸ್ಬೇಡಿ. ನೆಕ್ಸ್ಟ್ CH2OH, CNOH. Do you get it? Okay, here this carbon atom attached OH group at left side and CN group at right side. Okay, then CHOH, next is COH, H, COH, H, CH2OH. You have to carefully write the H and OH, which is should be present on the left side and which is should be present on the right side. Mainly you have to know about that. This is the reaction with hydrogen cyanide. Fructose reacts with hydrogen cyanide. It gives a cyanohydrine. Okay, this is called it as a cyanohydrine. Okay, next is third one with phenyl hydrazine. With phenyl hydrazine, what will form? Fructose reacts with phenyl hydrazine. It gives a osazone, same as it is in the glucose. Okay, first you have to write the structure of fructose. This is open chain structure. Here I am writing the open chain structure of fructose. Okay, then C double bond O, CH OH, COH, COH, H, okay, then CH2OH. Okay, then this is reacts with C6H5NH2. Okay, here excess is used in this reaction. You have to mainly observe that in the structural elucidation I was explained you what the configuration is same at C3, C4, C5. It means these atoms should not be changed, but this phenyl hydrazine is react with C1 and C2. Okay, that is the main thing I was explained. C double bond N, NH2, H, okay, plus C double bond N, NH2, C, H, OH, COH, H, COH, H, CH2, OH. Okay, this is osas zone. Here there will be changes only occur at C1 and C2 carbon atom. Here 3, 4, 5 and 6. 3, 4, 5 carbon atom should be same as it is in the glucose. Okay, glucose also contains HOH, OHH, OHH in the 3, 4, 5 carbon atom. Okay, this is all about the reaction with phenyl hydrazine. Next is reaction with concentrated nitric acid. Reaction with concentrated HNO3. It means oxidation or reduction. What will taking place? Oxidation will be taking place. Oxidation. Okay, here you have to write the structure of nitric acid. CH2 OH, C double bond O, C H OH, C OH, H. Okay, then C OH, H. ನಿಮಗೆ ರಿಯಾಕ್ಷನ್ಸ್ನ ಕೇಳಿದ್ರೆ ಸ್ಟ್ರಕ್ಚರ್ ಸಮೇತ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಬೇಕು. ಓಕೆ, ಆ್ಯಂಡ್ ದಿಸ್ ವಿಲ್ ರಿಯಾಕ್ಟ್ಸ್ ವಿತ್ ಕಾನ್ಸಂಟ್ರೇಟೆಡ್ HNO3. ಹಿಯರ್ tartaric acid and the glycolic acid is formed. Here COOH, COH, H, then CH, OH, COOH. Okay, tartaric acid plus CH2OH, then COOH, glycolic acid. Okay, this is all about the reaction with concentrated HNO3. Here you have to observe that the fructose should be cleaved into two different compounds. Okay, and in that the parent compound contains 6 carbon atom, but here in the product there will be lesser carbon atom compared to parent. ಯಾಕೆಂತಂದರೆ ಇಲ್ಲಿ ಕ್ಲೀವ್ ಆಗಿರುತ್ತೆ, ಬ್ರೇಕ್ ಆಗಿರುತ್ತೆ. So that's why they have a lesser carbon atom compared to parent carbon atom. Okay, ಪ್ರಾಡಕ್ಟಲ್ಲಿ ಕಡಿಮೆ ಇರುತ್ತೆ, ರಿಯಾಕ್ಟೆಂಟಲ್ಲಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ಒನ್ ಈಸ್ reduction reaction. One is catalytic reduction and another one is hydrogen iodide. Okay, if fifth one is with hydrogen iodide. Here reduction will be taking place. Reduction means addition of hydrogen or removal of oxygen. First you have to write the formula of fructose. ಪ್ರತಿಯೊಂದಕ್ಕೂ ನೀವು ಫಾರ್ಮುಲಾ ಆಫ್ ಫ್ರುಕ್ಟೋಸ್ನ ಬರೆದು ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಬೇಕು. COH, H, CH2OH. Okay, here hydrogen, sorry, here there will be not, point is not present. hydrogen iodide in the presence of red phosphorus, what it will be formed? N-hexane. Here this will be the bond line structural formula, N-hexane. Here count it, 1 2 3 4 5 6. Okay, here this like 1 2 3 4 5 6, and in the ends HH hydrogen atom is present. This end and this end as a CH3 group, and other is CH2 group. Okay, this is N-hexane is formed, and another one is catalytic hydrogenation. Catalytic hydrogenation means, sixth one is catalytic hydrogenation. This catalytic hydrogenation is the what? Addition of hydrogen in the presence of catalyst, hydrogen molecule. Here the product is formed is sorbitol. Sorbitol, it means 6 hydric alcohol is hexahydric, not a 6 hydric. Hexahydric alcohol is formed. Here HOH, COH, H, COH, H, CH2OH. Okay, this is the sorbitol. Here you have to know about that. ಇಲ್ಲಿ AL ಅಂತ ಬರಿಬೇಡಿ, OL ಅಂತಾನೆ ಬರಿಬೇಕು, because it is alcohol. How many OH group is present? 1 2 3 4 5 6. Okay, so hexa alcohol, and then how many hydrogen is atom is present? 1 2 3 4. Okay, so then in that hexahydric alcohol, 6 OH group is present in the molecule, so it is called it as a hexahydric alcohol, that is sorbitol. This is all about the reactions with fructose. Okay, and in that I will comparing the structural elucidation and reaction with fructose. You have to see here you have to observe the structural elucidation of fructose. First one is, we know that C6H12O6, and in that second one is the fructose on catalytic hydrogenation is reduced to sorbitol, a hexahydric alcohol is formed. Is it right? Here you have to see this fructose reacts with catalytic hydrogenation and it gives the hexahydric alcohol, that is sorbitol. How many alcoholic group is present? 1 2 3 4 5 6. Okay, this is one point. And next, continuation on complete reduction with concentrated HI in the presence of red phosphorus. Okay, N-hexane is formed. Here hydrogen iodide is acts as a reducing agent. Here see this fructose reacts with hydrogen iodide, it gives a N-hexane. N-hexane means in the terminal end we have a CH3 group and other 4 have a CH2, and it can conclude that it has a linear chain, not a branched or a ring structure. Okay, next, third one is fructose forms cyanohydrine and an oxime. Okay, fructose forms cyanohydrine and an oxime, where here you have to know about that when fructose reacts with hydrogen cyanide. Okay, when fructose reacts with hydrogen cyanide, this oxygen and hydrogen should be bonded to OH and CN is attached to keto group. Second position alli keto group jothe react agutte, so it is cyanohydrine. Do you get it? Next is with phenyl hydrazine. Okay, excess of phenyl hydrazine, sorry, not a phenyl hydrazine, hydroxylamine, it gives a oxime. Sorry, phenyl hydrazine alla oxime. With hydroxylamine NH2OH Here removal of water molecule, you have to carefully observe removal of water molecule, oxygen atom from the keto group and 2 hydrogen atoms from the hydroxylamine, and then C double bond NOH group is attached, so oxime is formed. So we can conclude that these two have a keto group. Okay, these two have a keto group, so that's why it forms a cyanohydrin and oxime. Okay, next fourth one is fructose reacts with acetic anhydride and forms fructose pentaacetate. Here they don't have a reaction. Okay, but you have to know about that. This fructose reacts with acetic anhydride and forms a 5-pentaacetate. Here you have to see this 1 2 3 4 5. 5 OH group is present, so OCH3 group is attached to that OH group. In the place of OH group, OCH3 group is attached, so it forms a pentaacetate because it has a 5-hydroxyl group. Why it forms only pentaacetate means because the fructose contains only 5-hydroxyl group. Okay, then fructose on oxidation with nitric acid gives a mixture of tartaric and glycolic acid. Okay, ಇಲ್ಲೇನಾಗುತ್ತೆ concentrated HNO3. This fructose reacts with concentrated HNO3. This is oxidation. It gives the tartaric acid and glycolic acid. Okay, tartaric acid ಮತ್ತು glycolic acid ಬರುತ್ತೆ, but you have to comparing that it has a lesser carbon than the parent fructose. Okay, you have to observe here, this have a 6 carbon atom, here this have a 4 and this have a 2 only. So that's why we can conclude that there will be presence of C double bond O. So that's why it cleaves the molecule. Okay, next one is both glucose and fructose form same osazone. Osazone ಯಾವ ರೀತಿ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ ಅಂತ ಅಂದರೆ ಇಟ್ ರಿಯಾಕ್ಟ್ಸ್ ವಿತ್ phenyl hydrazine. Okay, phenyl hydrazine ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದರೆ therefore the configuration at carbon 3, carbon 4 and carbon 5 are same as that of glucose. Okay, here you have to see this in the 3 4 5 same as in glucose also and also in fructose, so it is reacts with phenyl hydrazine. The configuration is same at 3 4 5, but the phenyl hydrazine reacts with only carbon 1 and carbon 2 position. You have to know about that in the fructose. Okay, there will be osazone is formed at 1 and 2 carbon atoms, but in the 3 4 5 it has a same configuration as well glucose as well as in fructose. This is all about the reaction of fructose and structural elucidation. You have to compare it. Okay, here then don't give a acetic anhydride reaction. You have to know about that. In the place of OH group, OCH3 group is attached. Okay.